Okay, so in this lesson, we're going to talk about radicals and simplifying radicals. Um, the radicand, and we'll talk about the radicand in a little while, but the radicand could be a number, it could be a variable, it could be a combination of numbers and variables. But this will be part one. Okay, so first of all, let's just look at some examples of what radicals look like. So these are examples of radicals, like the square root of 5. All right, now notice I use the word square root. So this means square root of 5. That's how you read this. All right. The cube root of, let's say, 8. All right, cube root of 8. So remember, this is read as the cube root of 8. Let's say the fourth root of 6x squared. Fourth root of 6x squared. So fourth root of 6x squared, and so on. All right, so in particular, though, I want to mention a couple of things. All right, so there's the words index that we need to look at. So what do I mean by index? There's the word radicand, R-A-D-I-C-A-N-D. What do we mean by that? Okay, so when I read the square root, so in the word square root, you see the word square. So when you think of square, you think of the number 2. Okay, something raised to a second power. So the index of all these radicals, let's look at this one. This is probably easier to look at. The index is 3. So that's your index. So when I said cube root, so this was a cube root of 8. Now notice where it's located. Make sure you understand where it's located. It's located right next to this radical symbol. So right above it. Okay, it's not in front. Don't make it look like 3 times the square root of 8, because that's not a 3 times the square root of 8. That's the cube root of 8. So it's very important. It's very important you know how to write this. So again, don't write it as when you write the notation. Don't make it look like this. Don't make it look like that, because that looks like 3 times the square root of 8. All right, so be careful. Don't write it like this. Make it look like an index. Make it look like an index. It should be right above that symbol right here that I'm drawing, right above this. Okay, and same thing here, right above this. So here's your radical symbol right here, and there should be right above this. So there's that 4. Remember, the 4 is called the index. That's your index. All right, so that word's important. Now, we see where this was a 3. You could actually see the 3. You could actually see the 4. Here, you don't see a number. Now, be careful. I'm going to go ahead and make this a little bit better. Don't confuse the fact that you don't see a number with a 1. This is not a 1. Usually, sometimes in mathematics, when you don't see something, it's understood to be a 1. Like x, the exponent is understood to be a 1. The coefficient's understood to be a 1. Well, that's not the issue here. So if you don't see a number here with the radical symbol, that's really understood to be a 2. All right? We just don't write the 2. So if it's a square root, you just write it. Like if it's a square root of, let's say, 10, you just say square root of 10, just like this. Don't put the 2. It's understood to be a 2. Okay? So it's very important you know that. That's how you write the notation. All right, so now we know what an index is. Now the radicand is just the part that's under the radical, like this. This is the radicand. So the 5 is the radicand. The 8 is the radicand. The 6x squared is the radicand. Okay? All right, so a little bit of terminology. That's radicand. A little bit of terminology. All right? Okay, now let's kind of review something else as well. Okay, so in a previous course, you learned this. You learned that to find the square root, and we're going to talk about square root for right now. To find the square root of a number a, we find a number that was squared to get a. All right, let me read it again. To find a square root of a number a, we find a number that was squared to get a. right, so here's what I mean. Suppose I want to find the square root of 49. Suppose I want to find the square root of 49. So according to this, to find the square root of 49, I find a number that was squared to get 49. So for example, 7 squared equals 49. But that's not the only thing squared that's equal to 49. The only integer squared that's equal to 49. There's another integer squared that equals 49, and that is negative 7 squared also equals 49. Because remember, negative 7 squared means negative 7 times negative 7. So a negative times a negative is a positive. All right, so far we based on this is what we found. To find the square root of 49, we find a number so that when we square it, we get 49. We find a number so that when we square it, we get 49. And I'm using square because this is square root. Okay? All right. So then we say this. We say the square root of 49 are 7 and negative 7. So there are two square roots of 49, 7 and negative 7. So when you find, in words, if someone says, find the square root of 49, you got to think in your mind, well, what squared equals 49? 7 and negative 7. So the square root of 49, there are two of them. I guess I should put square roots here. There are two of them, 7 and negative 7. So it's kind of like if someone said find the square root, again I'm using square root for right now, of let's say 64, of 64. So what number squared is 64? That's what you asked. So whatever that number is, that's your square root. Well, we all know that 8 times 8 is 64, but that's not the only one. Negative 8 times negative 8 is also 64. So the square roots of 64 are 8 and negative 8. Okay? All right, a couple more terminology with this, and that's this. Now, here's how you read this in terms of notation. So someone could say this. Someone could say, all right, I want you to find this. So remember this right here. This means the square root of 64. And then someone could say, all right, I want you to find this. All right, so when someone says find the square root of 64 in words, they're actually meaning these two things. They want you to determine, well, what is the positive square root of 64 and what is the negative square root of 64. Now again, we are talking only about square roots. We're not talking about cube roots, okay? And that's all we're going to look at in this particular lesson for today, square roots and cube roots. So for square roots, remember there are two, when someone says find the square root of a number, there are two answers. So this right here, where we're looking at the positive component, that's called the principal square root, P-R-I-N-C-I-P-A-L, principal square root, or the principal roots, principal square root. And this right here is called the negative square root. All right. So usually they'll just say find the positive square root of 64. But remember, another word for positive square root of 64 is the principal square root. Okay, principal. Principal is the positive component versus the negative. Okay. All right. So that's your terminology. Okay. Now let's look at this example. Let's suppose you want to find. And by the way, in this lesson, we're going to assume that when you have variables, assume that variables represent non-negative real numbers. Okay, assume that variables represent non-negative real numbers. Now, this right here, you're not gonna understand what that means in this lesson, but in the next one you will. Okay, but that's what the direction says. Assume that variables represent non-negative real numbers. Okay, so in the next lesson you'll understand how important that phrase is. All right, so let's look at this example. Number 1. So the direction is going to say simplify. All right, number 1. Okay, square root of 100. Now notice that this is the principal square root. Okay, so they're already telling you which one they want you to find. They want you to find the positive square root of 100. All right, so they're not saying in words, find the square root of 100. They're saying they want you to find the principal square root of 100. Okay, so in your mind, you're thinking, all right, since my index is 2, I need to find out what number squared is 100. All right, now remember, I want the principal square root, so I want the answer to be positive. So the answer is 10, not negative 10, because I only want the positive square root. So the answer here is 10, because 10 times 10 is 100. All right, so the square root of 100 is 10. Number 2, let's suppose we had the square root of 1/4, like this. All right, so again, principal square root, positive square root. So what squared equals 1/4? That's what you're asked. So always think like this. Always think in your mind, what squared is 1/4? When we do the cube roots, you're going to think the same thing. That's going to help you. Well, what times itself is 1/4? What fraction times itself is 1/4? Well, it's 1/2, because 1/2 times 1/2 is 1 times 1 is 1, 2 times 2 is 4. So the answer is 1/2. So the square root of 1/4 is 1/2. Number 3, suppose we had this. All right, now I want you to find the negative square root. So the negative square root of 36. Well, first of all, let's look at square root of 36. So 36 is equal to what squared? All right, so the answer is 6. All right, but I want the negative 6. So this is negative 6. All right, so negative, don't forget to bring that in, and this is just 6. All right, number 4, so the answer is negative 6, because negative, now be careful, this part right here, 6 times 6 is 36, right? But you want this to be negative, so you want the negative square root. All right, now let's look at this one. Okay, now this is going to be a variable. So again, we're going to assume that all variables represent non-negative real numbers. You're not going to understand what that part means until later on. But don't let the fact that you have a variable raised an exponent confuse you. When you have the radicands that are numbers, see, these radicands are 100, 1/4, 36. So those are numbers, so it makes things a lot easier. Here, the radicands of variable raised to a power. It's an expression. But use the same idea as this. So you're asking yourself, what squared is x to the 10th? That's what you're asking yourself. What squared is x to the 10th? Now, in a later section, you're going to use the idea of rational exponents, and then it'll make things a lot easier. But this section is not dealing with rational exponents. You just got to think about what this really means. This means this. So what squared is x to the 10th? Well, you got to remember some things from last semester. Like when you have the power rule, when you have a power raised to power, you multiply. So I need you to understand that x to the 10th is the same thing as saying x to the 5th squared, because 5 times 2 is 10. All right, so to figure out what goes inside this parentheses, here's a little trick. See how this is 10 and my index is 2? Just divide 2 into 10, and that will tell you what this needs to be. So always make sure it's correct, though. When you have a power raised to power, you multiply. Also, you know that x to the 5th squared means x to the 5th times x to the 5th. So using the product rule, when you multiply like bases at exponents, you get x to the 10th. So the answer is going to be x to the 5th. That's your answer, whatever this is. Okay? All right, so another example, let's suppose we had the square root of x to the 18th. Again, assume that all variables represent non-negative real numbers. So 0 or anything positive. All right, well, using that idea, what squared is x to the 18th? X to the 18th. Well, if you can't figure out this part out real quick, just think. 18 divided by my index, and x is 2, I get 9. So think to yourself, is that going to be x to the 9th? Well, yeah, because remember last semester, when you have a power raised to power using a power rule, you multiply the power. 9 times 2 is 18. Or you could use what we just did here. X to the 9th squared means x to the 9th times x to the 9th. When you multiply like bases, you add exponents. So you get x to the 18th, which is what this was. So my answer is going to be x to the 9th. Okay? All right. Now let's look at this one. All right. This was, I mean, this would be the example. Let's just put this as number 5. Okay, number 6. You have the square root of 16 y to the 6. 16y to the 6. Now let's just continue using the idea from this section. So you're looking for the principal square root. So basically, what times itself is 16y to the 6? That's what you're asking. What times itself is 16y to the 6? Well, the 16 part's easy because 4 times 4 is 16. So that's a 4 right here. Now let's think about y to the 6. So 6 is my exponent. My index is 2. 6 divided by 2 is 3. So let's see if y cubed works. That's a cube, y cubed. Let's see if y cubed works. All right, so let's think about what this is. So 4y cubed times 4y cubed is 4 times 4 is 16. Y cubed times y cubed. When I multiply like bases, I add exponents. That's y to the 6, and that's what I wanted. So this part right here is your answer. So the square root of 16y to the 6 is 4y cubed. Okay? All right, number 7. Suppose I had the square root of 36, y to the, let's say 24th power. Square root of 36 times y to the 24th power. All right, well, again, let's think about what we want to do. What numbers, so the square root of 36y to the 24th means what number squared is my radicand, 36y to the 24th. Remember your radicand. Okay, the 36 part is going to be easy because 6 times 6 is 36. So I know that 6 has to go in here. Now let's think about y to the 24th. Think about what I'm doing. 24 divided by 2 is 12. So let's see if y to the 12th works. So is 6y to the 12th squared going to give me this? Well, let's use last semester. 6y to the 12th times 6y to the 12th. That's what that means right here. 6y to the 12th squared means this. 6 times 6 is 36. Y to the 12th times y to the 12th. When I multiply like bases, I add exponents. So I get y to the 24th, which is what I wanted. So this right here is your answer. So I get 6y to the 12th. Okay, notice that in all the problems we've done, just be aware, in all the problems we've done, my answer did not contain a radical. Did not contain the radical symbol. See? X to the 9th. I didn't say the square root of x to the 9th. It is x to the 9th. It is x to the 5th. It is a negative 6. It is a 1/2. It is a 10. Not the square root of 10, not the square root of 1/2, and so on. Okay? Now, in another section, you're going to have a radical in your answer, but that's not what this is. Okay, make sure you understand how to get these. So basically, when you think of perfect squares, these are perfect squares. 100 is a perfect square. 1/4, the denominator 1 and 4 are perfect squares, so you get this. 36 is a perfect square, so you get 6. X to the 10th can be written as something squared, so you can think of x to the 10th as a perfect square, meaning that expression can be written as x to the 5th times itself, and so on. Okay, so now let's look at cube root. Same idea though. All right, so this is square root. Now we're going to look at cube root. Okay, suppose I had number 8. Suppose I had the cube root. Notice the index is 3. And my radicand is 64. 64. So the cube root of 3, the the cube root of 64. So the index is 3, and my radicand is 64. Now, just like we did here, this time you're going to ask yourself, what cubed, not squared, cubed, because that's your index, is 64. So do this in your head. Don't use your calculator. Don't rely on your calculator for this section. So what times itself 3 times is 64? So you may say, well, let's try 2. 2 times 2 times 2 is 8. So that's not right. If you try 3, 3 times 3 times 3 is 27. That's not right. If you try 4, 4 times 4 times 4, let's see, 4 times 4 is 16. 16 times 4 is 64. So 4 goes in here. And so this is your answer. So the cube root of 64 is 4. Just 4. Not the cube root of 4. Be careful. It is 4. Cube root of 64 is 4. Okay, number 9. Suppose you had the cube root of 1/8. All right. So a while ago we did one where we had the square root of 1/4. So notice my index was 2, so I use the exponent 2. And so we asked ourselves, what number times itself, what fraction times itself twice as 1/4? And we saw it was 1/2. So here, same thing. What fraction times itself 3 times is 1/8? So if you said 1/2, you're correct, because look, 1/2 times 1/2 times 1/2. So let's check it. 1/2 times 1/2, well, let's do this. 1 times 1 times 1 is 1. 2 times 2 is 4. 4 times 2 is 8. All right, so you get 1/8. So this is your answer. So the cube root of 1/8 is 1/2. All right, number 10. Suppose we had the cube root of -1. All right, cube root of -1. Okay, well, same idea. Something cubed. I want to see what cubed is going to be a -1. All right, so if you said -1, you're correct, because a -1 times a -1 times a -1 is a -1. Think about it. -1 times -1 is a +1, because a negative times a negative is a positive. And a +1 times a -1 is a -1, which is what I wanted. So the cube root of -1 is -1. Okay, number 11. Suppose you had the cube root of x to the 12th. The cube root of x to the 12th. Okay, so think about how we did this one, the square root of x to the 18th. All right, so remember we asked ourselves what squared, and we did squared because the index was 2. What squared is 18? And remember how we did this also, if you couldn't figure it out right away, we said 18 divided by this index is 2 is 9, and so that's how I got the x to the 9th, and we checked. Always check to make sure you're correct. So we use that same idea here. It's the same idea. So what cubed is x to the 12th? All right, so 12 divided by 3 is 4. So let's see if x to the 4th works. All right, remember how we got the 4. 12 divided by the index 3 is 4. So let's check it. X to the 4 cubed means x to the 4 times x to the 4 times x to the 4th. And remember our product rule from last semester. When I multiply like bases, I add exponents. 4 plus 4 plus 4 is 12. So I do get x to the 12th. And so this right here is your answer. So the cube root of x to the 12th is x to the 4th. Not the cube root of x to the 4th is just x to the 4th. It's important that your answer does not include a radical here. Okay, number 12 rather. All right, this part of this lesson is fairly easy. All right, number 12. Let's suppose we had the cube root of 8x to the let's say 15th power. 8, the cube root of 8 times x to the 15th power. Now remember also in this lesson, there's directions. Assume that the variables represent non-negative real numbers. Again, you don't know what that means until later on. Okay, so just like we did this one, number 6, just like we did number 6, you're going to ask yourself what times itself 2 times is the radicand 16y to the 6. And remember how we did this. We start with the 16 first. That was the easy part. 4 times 4 is 16, so I knew a 4 went in here. And then for y to the 6th, I just did it like the previous one. Kind of cover the 16 and say 6 divided by the index 2 is y cubed, and let's see if it works. And then it turned out that it worked. So we do the same thing here. What cubed is the radicand? And my radicand is 8x to the 15th. So let's check the 8 first. What times itself 3 times is 8? Okay, 3 times. So the answer is 2, because 2 times 2 times 2 is 8. Now let's do the x to the 15th. If you need to, say 15 divided by 3 is 5. So let's check and see if x to the 5th works. All right, so we have x to the 5th times x to the 5th times x to the 5th. So when you multiply like bases, we use the product rule. We add exponents. 5 plus 5 plus 5 is 15. So I get x to the 15th, and that's what I wanted. So this right here is correct. This right here. So the answer is 2x to the 5th. Okay. All right, number 13. Suppose you had a cube root of negative 27 x to the 9th. Cube root of negative 27 x to the 9th. All right. So again, let's use this notation. So what cubed is the radicand? And my radicand this time is a negative 27 x to the 9th. Okay, that's my radicand. Well, let's look at the negative 27. So what times itself 3 times is a negative 27? So what times itself 3 times is a negative 27? So if you said negative 3, you're correct. Because a negative 3 times a negative 3 is a positive 9. Remember, negative times a negative is a positive 9. And a positive 9 times a negative 3 gives me negative 27. So I know that a negative 3 goes in here. Now let's do the x to the 9th. So if you can't figure out right away in your mind what goes here, then think of, well, what's 9 divided by 3? Well, 9 divided by 3 is 3. So let's see if x cubed works. So x cubed times itself 3 times is going to be, when I multiply like bases, I'm using the product rule. When I multiply like bases, add exponents, I get x to the 9th, and that's what you wanted. So this right here is your answer. So negative 3x cubed. Okay? All right, so that's part 1. So part 1 was fairly easy. I needed you to understand the idea of principal square root, negative square root, the terminology in terms of index, radicands, and what finding square roots and cube roots mean. So like the square root of 100 means what times itself 2 times is the radicand. Things like this. Okay, now this section was easy. In the next section, we're going to discuss, well, what happens if this expression or these words are not there. So in the next section, that's where we're going to state that the variable can be any real number, and so we're going to see what that means. Okay, all right. So that's the end of this section.